Hello and welcome to your note guide video for exponential growth and decay. So we will be using our properties of exponents to help us explore this topic. So an exponential function is a function in the form of y is equal to a times b raised to the x power, where a cannot equal 0, because otherwise we would have a horizontal line. Okay. B has to be greater than 0, so it can't be negative. And B also cannot equal 1, because that too will cause a horizontal line. Okay, so now that we have the basics of exponential functions, let's move on to exponential growth. So exponential growth has two criteria. Your A is greater than 0, and your B is greater than 0, or greater than 1. Okay? Exponential growth models is our equation is y is equal to A times the quantity of 1 plus r raised to the t power. Okay. Now each of those letters represent something. So A is our initial or starting amount. Okay. R is our rate, and that needs to be written as a decimal. Okay, and it's typically as a percent. And then T is our time. So how long does it take for this item to grow? Now this whole set of parentheses, so 1 plus r, is called our growth factor. Okay, so now let's look at this example together. You put $125 in a savings account that earns 2% interest compounded or calculated yearly. You do not make any deposits or withdrawals. And how much money will you have in 30 years? Okay, so writing our equation, let's first look at what we know. So we know that we have our starting amount of 125, that we earn 2% per year, so one time a year. And then we don't make any deposits or withdrawals, so we're not taking any money out or putting any more in. And we want to know how much is in it after 30 years. Okay, so let's fill in our equation for what we know. So y we don't know. So y is equal to our starting amount of 125 times parentheses, 1 is always there, plus our rate, so 2%, 2% as a decimal is 0.02, so plus 0.02, raised to the 30th power, okay, for our time of 30 years. So now, when you plug this into your calculator, I'm going to type it in exactly how you see it. 125 times parentheses, 1 plus 0.02, close parentheses. And then to get this to the 30th power, hit caret 30. Now, I really want you to practice doing this just so that you are getting used to how you plug it in. And when you do plug it in, you get that y is equal to $226.42. So after 30 years, you will have $226.42 in that savings account. So that's exponential growth. Now let's look at an exponential decay video or example. So exponential decay, your A is greater than 0, just like exponential growth. However, this time your B is in between 0 and 1. So it's a fraction or a decimal. Okay? The model is the exact same as exponential growth. However, instead of adding the rate to 1, we're going to subtract it. So we have y is equal to A, or our initial or starting amount, times 1 minus our rate raised to our time. Okay? So a farmer bought a tractor in 1999 for $30,000. The value of the tractor has been decreasing at a rate of 18% per year. What was the approximate value of the tractor in 2005? Okay, so plugging in what we know, y we don't know is equal to 30,000, because that was our initial amount, times 1's always going to be there, r, or minus. Now our r is 18%, so 18% as a decimal is 0.18, so minus 0.18, to the certain power. Okay. Now that power, we need to find 2005 minus 1999. That's 6 years, so to the 6th power. So again, typing this exactly into your calculator, so 30,000 times parentheses 1 minus 0.18, close parentheses, raised to the 6th, you get that y is equal to 9,120 and 20 cents. So after 6 years, your tractor is now only worth $9,120.20. Okay, so that's a big difference going over just a 6-year time span. Okay, now I want you to work on those 4 examples on the back of this note guide, and then check back on part 2 of the video to see how you were doing.